Welcome to another episode of IDology, the industrial design podcast. My name is Voytek Holysz, and here I pick the brains of industrial design experts. It might sound abstract, and it sure was baffling to me to hear how some companies neglect technical documentation and the reasons for it. I sat down with Piotr Dalewski, a mechanical design engineer, and Rafał Piłat, senior designer and CEO here at Mindsailors, to discuss why on earth would anyone neglect technical documentation. Let's dive in. Okay, guys. So maybe let's start with the basics. What is technical documentation, and why was it developed at some point?
I think if you want to start with basic, I think we should start with a historical background of it, just to give an overview for our listeners. Sketches and drawings were used in product development since ancient time, but the need to develop such precise components started in late 1800s for mass production.
So it was like when the need for mass production came in,
Yes.
it needed to sort of evolve into a more complex documentation type?
When these firearms required quite precise for its times parts. So for example, if a part of a musket was wore up, and it was much easier to replace one part instead of creating whole new musket.
Yeah.
So that's how it was done. But
So as usual, war pushes us forward.
yes, indeed. The need to create precise object started. So that's why it influenced whole manufacturing process, because after the parts were made, it required to measure and test them if they fulfill some kind of expectations.
But you're talking about muskets, so that was before the Industrial Revolution, before mass manufacturing, or was it about the same time?
I would say it was like the first industrial revolutions on mechanizations, and to develop mechanism, you need precise parts, and to have precise parts, you needed some kind of documentation to follow during the manufacturing.
Yeah, so like different stages could better sort of communicate with each other.
Yes, that's what I like to think about technical documentation. That this is a unique language between the designer, manufacturer, and also quality control. So just like the software engineers have their programming languages, mathematicians and physicians got their formulas, mechanical designers have technical drawing. The rules of this language is defined in international technical standards.
Okay, so like you said with the muskets, no matter who is going to manufacture a part, they all understand the same technical language, sort of, and they are able to make the part back then probably more or less exactly the same. Nowadays, it's probably way more precise.
I would say that these parts, even though they were manufactured by different companies, they have to fulfill the same requirements. So they might deviate from each other, but they fulfill some kind of standard.
Yeah, like tolerances. I only imagine that with muskets, those tolerances or details weren't as precise as we have them today with today's technology. So
yeah, that was just the example, but those standards come from. Although today we use 3D modeling software, there are many features we are not able to show only via geometric. I would say it's the kind of material we're using for the manufacture, maybe some special steel grade or special alloy, the hardness of the material, so it might require some heat treatment or special coating, the finish of the surface, for example, roughness. So there are many things we should take into account, and we are not able to just show them on 3D model.
I understand that this is sort of a language of precision of communication, sort of, so that no one misinterprets any directions given to manufacture an object, but still, no two objects are totally like identical or perfectly shaped, even though they have technical documentation. So how does that work?
We must be aware that there's no such thing as perfect dimension in the real world. We've got them only on drawings, and these are called nominal dimensions. But we need to be aware that each part deviates from the nominal dimensions, no matter if it's 1/10 of a millimeter or 1/100th. But there's always slight difference, and it depends on which devices we're gonna use, which methods to measure them, because there's always gonna be some kind of difference, maybe even the nanometers.
Okay, so it's like these nominal dimensions, they are sort of like the perfect state that we aspire to achieve, but it's always a bit imperfect in a way.
Yes, that's why we use geometrical dimensioning and tolerancing. So each important feature, we have to define how different it can be from the nominal.
Okay.
And this feature, after the part is manufactured, this feature should be measured and then tested if it fits the tolerance.
Okay. So achieving like perfect quality is not about achieving perfect dimensions according to the documentation.
Yes, that's actually quite funny because everyone has different definition of quality.
Yeah, that's true.
So, according to the books, the quality is an inherent feature of the object, device, or maybe some kind of service that shows how much it fulfills the requirements of the customer. So those requirements should be specified somehow for the quality assurance to test them. So that's why we describe how different the object can be from the nominal dimensions placed on the model. But we need to be aware that in real life, they are not the same.
Yeah. Rafał, what is good quality for you in real life?
I guess it's you could say that quality is subjective because it's always a matter of how much time and money you want to spend on perfecting something. And of course, there are technologies which have simply limitations to the quality of dimensions that you can achieve using this specific technology. Obviously, if you're going to use CNC for machining some parts, you can achieve excellent results in terms of tolerances, but that would require a large amount of time and precise measurement devices to simply verify it and to achieve such quality. And obviously, it's not always needed. Depending on actual use of the device that we are designing or even the parts, sometimes it's not even required for a part or area of a part to be super perfect in terms of keeping the dimensions. So I guess this is the quality as it sounds. It's very unspecified notion. We have to somehow reference the quality, as Piotr said, to depending on the usage, depending on the technology that we are using, and depending on the actual time and money we want to spend on this part, on making this part.
So the technical documentation sort of doesn't guarantee quality of an object, but more the quality of the manufacturing process itself. Because like you said, we both actually, that quality is subjective. So sometimes if a thing is simply heavier, sometimes we just feel, oh, that must be worth more or be more, have greater quality just because of the weight. but not necessarily we check the seams between every material to make sure that yes, this is indeed of high quality.
So we can say these words are quite similar, but there's a difference between quality and precision. Sometimes for our designs to fulfill some requirements, we need precision. But if we make an object too precise, like you said, using very precise end mills for CNC machining or maybe EDM process to manufacture the part, we can have too precise part for our use, for our requirements, and it will multiply the manufacturing cost.
Right.
So to achieving good quality isn't the same as achieving very, very precise object.
Right.
So if we over-engineer them, we can increase manufacturing cost.
Likely so. Right.
You've mentioned before that technical documentation is, you see it as a language between designers and manufacturers and quality control. Yeah. But from what you're saying, it seems to me like still technical documentation is very focused on the manufacturing process. So for a designer, where in the design process should they start preparing or thinking about preparing the technical documentation?
We also call it often manufacturing documentation. So I would say it should be done before the manufacturing process, but it depends. If we are manufacturing and designing object and manufacturing in one company, we are able to speak with the machine operators, and usually they are used to manufacturing the similar objects. So in some cases we can avoid it. But in cases when we are talking with many peoples and we are not, sometimes we are not it often happens that these parts are manufactured somewhere in other country, maybe in China, and we don't have ability to talk with the operator. So we have to prepare these document of requirements. But usually, I would say it's even better to prepare a bit earlier documentation when we are quoting, because the better documentation we give to manufacturing company, they are the better documentation we give to our manufacturing companies, the better they can assess the costs, they can adjust the process, and they can adjust the machines they're gonna be used.
Or they can simply say that they cannot meet the criteria that we want, and this is an information for us that we need to look for a different manufacturer, because perhaps they might have, they might not have a machine that could that can handle such precision as we require.
I would like to say that the better documentation we deliver, the more accurate offers we get.
Okay. I remember, Rafał, you once told me that it happens, I don't know how often, that you get a 3D file from a client that says, hey, we have the designs ready, here they are, we're ready to go manufacture the thing. And is a 3D model technical, or can it be considered as technical documentation?
So I guess there is no good answer to this question, because you can, well, it all depends on your need. You may require just one part to be manufactured, and then you can use, well, any prototyping technology, even 3D printing, and you can use 3D printing for serial production as well. So I guess this is, to answer your question, I guess it's more related to actual need rather than technology.
Yes, but for the large volume production, we always prepare such documentation.
Right.
And there are also other kinds of documentation we need to take into the account. For example, declarations of conformity or some kind of international standards or risk management and risk analysis documents. But those documents are obliged by law when releasing the new product into the market. So these kind of documents we can prepare when we have the first working prototype or MVP. Manufacturing is always connected with a large investment, no matter if we order the injection molds or even the small batch of 3D prints. But if we deliver documentations, the manufacturer is obliged to test them, to check if the features we are looking for, the features that are important to us, those requirements must be fulfilled. And if we won't specify them, they won't be aware of them. So there's a high probability that we're gonna order flawed parts.
Right, and even if we receive parts that are flawed, and if you will have some kind of, if you want to fail, if you want to claim some kind of reimbursement or force the manufacturer to redo the parts, he might, or he or she might say that, sorry, we did it according to our best standards, and you did not define the precision or the dimensions that you require, and this is as best as we can. We did it as best as we can.
So not only it's a language, technical documentation is language between stakeholders, but also it's like a point of reference for times of trouble, sort of.
Yes, that's exactly what it is.
Okay.
Because this is your, let's say, reference for standard that you are requesting.
Okay. I understand. That's why sometimes a 3D model is simply not enough, and maybe in some simple cases it's okay. But the more probably complex an object is, and those connections between parts are so important, then the technical documentation best describes those connections, sort of.
Yes, I would say that's exactly how it is.
Okay.
Sometimes also we have to prepare the documentation for assembly process because some objects are that complicated that they require some kind of precise sealing or precise torque of fastening. And if we can have the best, perfect, high quality part that fulfill our requirements, but if we won't assemble them in a specified way, we can damage those parts. So that's also another thing worth taking into account.
Not every product consists of 2 or 3 parts, and sometimes quite the opposite. We did disassemble exercise machine, which I guess we could safely say has more than, I don't know, a few thousand of parts, and I can't imagine anyone assembling it just from memory and his knowledge from the 3D model. Obviously, different people model this device, and different people will assemble this device during the manufacturing process. So this is also assembly is also assembly documentation is also part of the documentation.
I just wanted to add that, in my opinion, the person responsible for manufacturing documentation should be the person who designed those parts, because we faced many problems when during our development process we delivered just first samples, first prototype, and customers were very happy with them. So they decided to stop the process, and they thought that it's enough to start the full volume manufacturing. And some other designer, let's say from their company or some freelancer, prepared the documentation for them. But he wasn't aware of the standards that we have to fulfill. So The consequence of that was that those parts weren't manufactured in the way they should be.
Yeah, I guess this is absolutely right. And I imagine a situation that you give, you handle a part which is a 3D model to someone who was not, who is just, who will just prepare the 2D documentation or 2D drawing for this part. And if he's not aware of, for instance, nominal dimensions of the part or how the part will be used in the full assembly, I think that this person won't be able to prepare a valid 2D documentation for this part, because this is part of the knowledge. How to prepare a documentation is also knowing what this part does and how it's going to be used. And as Piotr said, what's the technology that will be used to manufacture this specific part. So this is a critical thing that the designer and the person who is going to prepare the documentation, it can be either the same person or those people need to be well communicated to simply deliver a good quality documentation.
I can only imagine that if a client would decide to do what you guys described, like to stop the process and take it from there, it can only happen with unexperienced clients who probably, I don't know, they're searching for budget savings or something like that, because what you described sounds highly irresponsible and risky for a business. Is it difficult trying to explain or educate the client why preparing the technical documentation by the designers or the design company should do it? Is it just a matter of...
I guess it's a matter of time and money, because it might be... I imagine that someone who doesn't know what the actual aim of the documentation is, he might think that this is unnecessary expenditure during the design process. We have the 3D model, it's good enough. We don't need any kind of 2D drawing documentation,
yeah,
manufacturing documentation.
But you explain it to them, right? Why it's necessary.
Yes, of course. But sometimes, explanation is just not enough. I guess if you have, I don't know, false beliefs that you can, I don't know, manufacturing something without a 2D documentation, I don't know, unless you are, I don't know, a manufacturer who is able to I don't know, make the adjustment, etc. I guess there are some cases that you can live without any kind of documentation. If the person who is manufacturing is aware of the process, does know what the specific parts do. But in other cases, when we have a complex project, or when there I don't know, when there is risk simply of failure in terms of I don't know, quality of the parts that is going to be delivered. So I guess you need to treat the documentation as a reference point that you can go back and you have check for something, how it actually needs to be, what are the criteria for the specific part.
I would also like to say that our customers have different backgrounds, and it's different with the working with a company that working with a company that produces some kind of devices is easier than, for example, working with, I would say, for example, software startup. And in software development, the prototype is just an iteration of a code we can test, and it's not connected that much with the investment. We are able to do some changes and then try new iteration, new prototypes. And during the physical product development, we need to prepare those changes and we need to communicate them with a manufacturer. So I think when such clients see the working prototype, they are happy, they are excited, they think we are almost there, we got a working device. But in our industry, there's a large amount of money, time, and effort in scaling for the full volume mass production. So I think they might not be that aware of the difference
Okay, that's
because they're just not familiar with it.
yeah, sure.
So basically, that's why we're doing this episode.
Well, in another episode, we talk about educating our environment, clients, involving clients also. So I hope this will help someone. Okay, let's try to sum it up a bit. So I think it's obvious, but just let's reiterate. Why is technical documentation crucial, if not mandatory, to be prepared with every design?
I think the strongest point for me is trying to persuade a person that a technical documentation is security against unreliable manufacturer. So this is a reference point to which you can relate, to which you can go back to and have it checked if the parts that you're going to manufacture are made according to the standard that you are expecting them to be made.
We need to be aware that manufacturing can be very, very expensive. And in order to communicate in a proper way with a manufacturing team, with a quality control team, we need to speak the same language, even though we can be in other countries and we not see each other. So that's why we need to communicate the best way and the most precise way we can. And the technical documentation is a list of those requirements to accomplish the project.
It's a language of communications for engineers.
Okay, guys, I think you summed it up pretty well. So let's just leave the viewers with the notion that technical documentation is basically something that might be crucial to their business if they want to not burn too much money or waste too much time. Well, you can save your future self a lot of time and money if you don't make the same mistakes the companies we discussed on this episode did. As always, if you enjoyed this discussion, check out IDology, the Industrial Design Podcast, on YouTube, Spotify, and other podcast streaming platforms.